Here we go. We have a question, search in rotated array. So you have given a sorted rotated array of distinct elements, and our task is to find the index of the target key. So we have this example. In this we have a key. So key is present and key is present at index 8. So we need to return the index. In this case 6 is not there, so we need to return -1. In this case 42. So 42 is present at index 1. So let's try to build the approach. So I have taken this test case, and the brute force will be to check with each and every element. In this case the time complexity will be order of n, but we can do it better. So we will apply binary search. So first we have L here and R here, and let's suppose the key in this case is 3. So first step is to find the middle. So the middle will be this. Is our key equal to middle? No, key is not equal to middle. Then our next step is to check, is the right side sorted? Is the right side sorted? How do we check? We just need to check, is this value smaller than this value? Means our middle value is smaller than rth value. If this is the case, it means our right hand side is sorted. So the next step is to check, is the key present on right hand side? Is the key present on right hand side? How do we check? So we need to check, the key is greater than middle and the key is smaller than or equal to r. If this is the case, we are sure that our key is present on right hand side. So we will need to update our L. In this case key is present on the right hand side, so we have L and R here. Then our next step, we are again inside our while loop. The middle value is this, we have this. Then is key is equal to middle? No, key is not equal to middle. Then our next step is to check, is the left hand side sorted? Yes, left hand side is sorted. Sorry, right hand side. First we are checking our right hand side. Is our right hand side sorted? So our right hand side is sorted. Then is the key present on right hand side? Key is not present on the right hand side. Then it means our key is not present on right hand side. Key can be present on left hand side. Then we need to check, is the key present here? Is the key present here? It means key is greater than or equal to L and less than or equal to mid. Yes, key is there. Key is there on left hand side. So next step is to update our R. So our R will be middle -1. Then in this case the middle value is this. So middle value is equal to key. So we just need to return it. So first of all, our first step is to find the middle point. Then we need to check, is the right hand side sorted? If the right hand side is sorted, then we need to check, is the key present on right hand side? If the key present on right hand side, then we need to update our L to mid +1. If our key, if right hand side is sorted but our key is not there, for example we have L here, we have R here, and let's suppose we need to find 9. I'm taking 9. So middle value will be this. It is not equal to middle value. Our right hand side is sorted but key is not present on right hand side. We need to move on left hand side. So if this is the case, then we will move to left hand side, middle -1. We have already checked with the middle value. So this is the else if block. In the if block we need to check with the middle value. Then we have else block. Else block means our left hand side is sorted. Left is sorted. If left hand side is sorted, then we need to check, is our key present on left hand side? If the key is present on left hand side, so just move to left hand side. If the key is present on left hand side, we know left hand side is sorted and the key is present on left hand side, so we will move to left hand side. If the key is not present on left hand side, then we need to look on the right hand side. So that's all about the approach. Let's try to code this. So first we have an L and R. So we have this loop, and then we have middle. We are checking with the middle value. If this is equal to key, just return middle. Else our right hand side is sorted. We need to check. If the right hand side is sorted, then if the key is in the right hand side, so key is greater than mid but less than R. So just shift your L to mid plus 1. Update your L. Else our key is not on right hand side. We need to look on the left hand side. So we are looking on the left hand side. Then we have else block. Right hand side is not sorted, but left hand side can be sorted. If the key is present on left hand side, key is greater than L but less than mid. Key is present on left hand side, so just move on the left hand side, else look on the right hand side. So if we have not find our key, then just return -1. So that's all about the approach. Let's give it a try, and let's talk about time and space complexity. In this code, our time complexity is log n because we are using binary search, and our space complexity is constant. We have solved this question in the expected time and space complexity. Code is given in the description box. If you guys have any doubt related to this code, feel free to ask in the comment section. Give this video a thumbs up, subscribe to this channel, and thank you all for watching.